Okay, so I am Marek Maškrenec. I work as a firmware developer at Hardvario, and I'm going to talk about in-source test with Ztest. Just for those who do not know what Ztest is, it's a Zephyr library for writing automated tests. Here you can see a simple example of a test of a simple add function. What's good about Ztest is you can write tests for the native sim target or the QEMU targets which can run without hardware. So you can basically test or firmware without the real hardware. Also, Zephyr provides you with simulated devices. So if you, for example, need to test something with flash, you can just add to the device tree simulated flash, which is provided by Zephyr. Each Ztest or the test suite is a Zephyr application on its own. So you can basically, this is the main file, and then you add some kind of CMake list and app overlay and project conf, everything that you already know from writing Zephyr applications. And then you can run the test with the CLE tool Twister, which is made to be scalable because in Zephyr there is a lot of tests and they are run on a lot of platforms, so you need to kind of run them efficiently on multi-threaded and collect the logs from them. So what's the problem with, so here we can see the example of the test. You can compile it for the native sim target, and then if you run it, you just get some kind of summary of the test. You can see it passes. So the problem with Ztest that I often found is if you want to test some libraries or subsystems or modules, it's okay. This is also shown in the documentation. It's the intended use case, but often I would need to test static code or something that's in the application itself. And Ztest, because it is an application itself, you have to link against the code, which is not possible if we have this static function. Obviously, we will not know if it's correct if we don't test it. So I had to kind of come up with a workaround to allow me to do this. So the solution is to just put the test directly in the file, like this. Basically, we have this main function. This is the main file of the application, and we can just put the test in there. If we try this just like this, it will not work because Ztest provides its own implementation of main, so it will not compile. We have to do some additional steps. First is we define some kind of kconfig, which if we enable it, it will just will compile the test. If it's enabled, it's good to default it to no, because if we have multiple tests, it can prevent duplicates. Then we just put some preprocessor conditions to only compile the test if we have them defined, and the opposite, we will not compile the main if we don't have the test enabled. This is also useful. You can, for example, use this to write stubs for the test, so I can, if I'm testing, I can have a different device for something or an alternative implementation for some function. For example, I can define my own mutex locking, so it increases and decrements a counter, and then I can check if in all the paths of the code that is correct. This is the second step, and then we just have to create basically a blank testing application. In the CMake list, we just include the file we want to test. This is kind of tricky because we have the CMake list in the test/appmain folder, and then we have to go up the tree and include the main file, which is kind of hacky, and then we just enable Ztest and our test in appmain, and basically that's all. Just to recapitulate, we can put the test directly in the source files, and then we just include it in some kind of blank testing application, which itself doesn't need to have any code. The advantages are the tests are needle implementation, so we can kind of, if you are looking at the function while you are writing it, you can already see how it's used, how it should perform, what the results should be. It's also used in Rust test or Zig test, the same approach. We can also test private codes, static codes with static variables. If the function, we can access the global state, which we might not be able to access normally. Obviously, there are some disadvantages. It can like inflate the source file a lot. We can maybe work around with this with some includes and stuff like that. We also have to make sure that the source file, it compiles both in the test context and both as the application. So there are going to be a lot of if-defs, because every time we use some kind of Zephyr API, we might need to like do some kind of workaround. And obviously it's not the official approach. It's in the documentation. The documentation doesn't mention this approach. And while preparing this presentation, I had an idea that it would be possible to create an application, which if you just went into the application route, you could build it either as the application or as a valid Ztest test. So every file would compile either way, but I haven't tried it yet, but it would be very cool. So if you have any questions?